Hello everyone. So in this video I am gonna demonstrating target 8b, which is analyzing a sequential circuit to determine its operation. The circuit I have uh, taken that has two flip-flops, FF1, it's a J and K flip-flop. The Boolean equations for the circuit are D1 equals to Q0 times X, J0 equals Q1 X, and then K0 equals Kx prime, and Z equals Q1. The output comes from FF1 only. Still, it is a Moore machine. Now we'll go through the state table. So in state A, which is 0 0, if x equals 0, the next state stays A. If x equals 1, the next state becomes B, which is 0 1. In state B, which is 0 1, if x equals 0, the next state goes back to A. If x equals 1, the next state becomes D, which is 1 1. The next the state is C, it is 1 0. When x is 0, the next state becomes A. When 1, the next state equals to 1. The last state is D, which is 1 1. If x equals 0, the next state goes to A. If x equals 1, it stays in D. So this is my so now I'll mess something. Yes, I have to explain the output becomes because Z equals Q1, the output is 0 in state A and B. Since Q1 is 0 there, the output 1 states C and D. Since Q1 is 1, those states. Looking at the state diagram, the machine starts at A. From A, an input of 1 moves it to B, while an output of 0 keeps it at A. From B, an input of 1 moves it to D, and an input of 0 send it back to A. From C, any output send it back to 1, and from D, an output of 0 send it to A, while an output of A keeps it in D. The overall behavior in this machine starts A, waits for x to become 1, when moves to B, if x becomes 1 again, it moves to D, and then output becomes 1. Once it is in D, it stays there as long as x remains 1. If x becomes 0, the machine resets back to A. This makes it a Moore machine because the output depends only on the current state, not directly on the input. So I have written some summary over here. So if you want, like I don't have maybe enough time, or yes, I do have enough time. So this Moore machines uses a D flip-flop for FF1 and K flip-flop for FF0 with 4 states A through D. The output Z equals Q1. So Z is 0 in states A and B, and becomes 1 only when the machine reaches states C or D, making it a Moore machine because the output depends only on the current state, never directly on the input X. Starting at state A, the machine advances to B on x1, x equals to 1, then to D on x equals to 1 again, and once in a C or in a D, any x equals to 0 resets it back to A, while x equals to 1 keeps D stable. So that was, I think, all from me. I have did analysis of this circuit. So it is not a much. We have to just take the equation first, then write the table, and then draw the diagram and the summary I wrote. So in the short term, I can say there is an input, there is a two flip flops, DK flip flop and JK flip flop, D flip flop and JK flip flop, the CLR current state, and there is one output from the FF1. Yeah, and then I just wrote the equation. D is equal to Q0x J, K and Z, then the table, the diagram, and some summary about it. So I think that's all from my side. Thank you for watching the video. Thank you.